Right, so when it comes to SPDF configuration, right, in Jamb cases it comes in two forms, right? It's either you're given the SPDF configuration of an element and being asked to identify the element, that's in one case, or the other way around there, you'll be given the element and asked which of the following is the correct SPDF notation. The easier one there is when you're given the SPDF configuration. Right? How do you know? It's easy, just count the parts, that's all. For instance, say which element has this one here. I don't have to stress myself. Just count the part here. What's the part here? 2 plus 2, 4, plus 6, 10, plus 1, 11. Which element is number 11? Sodium. That's all. That's all. So that one is easier to be done. Right. The trickier one now is when they ask to provide the, what do you call it? The SPDF configuration. And those guys are so smart, they do it in two ways. They know that you know that what you have to do is just to count this man. So they'll give you the same thing here. They'll give you all of them will be 11, but the difference will not be what? The arrangement. So they now say example, now say which of the following is the correct SPDF configuration of, let's say, sodium. Alright, for sodium, now say A is this. A is 1s2, 2s2, 3s2. 2p, let's say 6, let's say 5, right? 6, 5, do something like this, right? Give you b, you now say 1s squared, 2s squared, 2p to the power 6, 3s by 1. Now, at this point now, if you want to say, what is the concept of saying you want to count the parts, it will fail you. Because if you look at this is how many here? 2, 4, 6, 11. This is 11. This is also what there? 11. So you can't follow the concept of saying you want to count the parts to fail it. So how do you know the correct thing to do? You have to master this one. So at this point now, it's no longer about counting the parts. It's not about what there? The order of arrangement. So it must be what there? 1s first, before 2s, before 2p, in this order. Are we good? Alright. Let's proceed please. Next up please. Valency. Next up please. Valency. I want to take points first before we'll do past questions, but let's go to the points first. Alright, so that we can actually I'll link up everything together. We'll proceed. Alright, this is our Valence please. Definition. Valency is the combining part of an element. Valency is the combining part of an element. The combining part of an element. You there? Full stop. Okay, let me ask this question. If an element is positively charged, what does it mean? If an element is positively charged, what does it mean? Huh? It's a metal. Okay, it's a metal. Right. Right. It's a metal, right? It's a metal. One heavy metal, right? I just mentioned this in class now. That's why I said I had to go and do everything. See, listen. We said this already. We said when an element is positive, what does it mean there? It has lost electron. That's what we said. Right. It has lost electron. Alright, okay. For an atom to be stable, comma, it must have either duplex, this way, duplex, or octet configuration. For an atom to be stable, it must have either duplex or octet configuration. By duplex configuration, continue. By duplex configuration, so for an element to be stable, comma, I said it must have duplex or octet configuration. By duplex configuration, comma, we mean it must have two valence electrons. by duplex configuration, we mean it must have 2 valence electrons. And by octet configuration, we mean it must have 8 valence electrons. By duplex configuration, we mean it must have what there? 2 valence electrons. And by octet configuration, we mean we have what there? 8 valence electron. So here's the punchline. Here's the punchline. If the number of, okay, before then, what's the valence electron? Before then, what's the valence electron? Huh? Paragraph. Valence electrons are the electrons found on the outermost shell of an atom. Valence electrons are electrons found on the outermost shell of an atom. So let's recall something, please. We did something here. Yeah? We did electronic configuration for 3 elements. The first one was hydrogen. This was what there? Just one, I mean. What was next there? Sodium. What was the configuration there? 2, 8, 1 there. 1, true? Next one was what there? Potassium. That was what there? 2, 8, 8, 1. So look at this. These ones are called valence electrons. The electrons on the outermost shell. So if I draw sodium now, sodium is actually 1 circle, 2, the second circle, 8, the last circle, 1. So the number of electrons on that last circle are called what there? Valence electron. That's the concept. So the electrons are what? The outermost shell of an atom. That's the concept. Now, question. Do you think, hold on. Do you think hydrogen, sodium, and potassium are stable? Are they stable atoms? Yes or no? No. Why? Because they are not octets. They are not also what they're duplex. For it to be stable, it must have 2 valence electrons, or what they're 8 valence electrons. So if it's 1, it's not stable. So hydrogen on this one is what? It's not a stable atom. Sodium on this one is what they're not a stable atom. Same thing with the potassium. That's the concept. Do you think calcium is a stable atom? Yes or no? Yes. Calcium, yes or no? Yes, no. Calcium is atomic number what? 20. What will be the configuration? 2882. With 2882, is it stable? Yes, that's duplex now. 2 valence electron. So yes, it's stable. So calcium is stable. Yeah? Calcium number 20 now. No, not just that now. No, not just that. No, because like which of them? Argon. Yeah. Check argon is atomic number what? 18. What's the configuration? 288. How many valence electrons there? 8. That's octet, so it becomes stable. So stability is a 280. It's not just octet. Also what there? Duplex. So it's not just noble gases. So when we say noble gases are stable, why is it stable? If I know that, I've answered that one before even telling you. I've told you the answer already. So why are they stable? Why are noble gases stable? Why? So this concept. So stability of atoms are hinged on 2 things, either duplex or octet. So if it's 2, it's stable. If it's 8, it's still stable. Alright, so that's the concept. Alright, so it's from this concept that we get what is called ions. Start writing ions. So here's the thing now. If hydrogen is not stable, how then does it become stable? Huh? Add an electron. Or will it donate? Will it add or will it donate? Donate. Huh? To add. You add to forward that too. Alright. Hydrogen. The hydrogen you know, is it H or H plus? H plus. What does H plus mean? It is losing. It's losing. So this one electron now, instead of adding one more electron, what will happen now? It will give back an electron instead. So it becomes what the possibility charge. That's the concept. That's how it works. What's sodium? Sodium is what there? Na what there? Plus. Abi? Remember the sodium ion, Na plus. What does it mean? Sodium is 281. Now, there are two ways for sodium to become stable. It's either this sodium will add one more to become 2, or it can easily just give out this one to become what there? 8. So what will sodium do now? Sodium will now give out this electron, to now lose electron. So it will lose one electron to become what there? Positively charged. That's the concept. So it becomes H plus Na plus. That's the concept. So now you see stuff like this. For instance, hold on. Chlorine. Chlorine, is it Cl plus, Cl minus, Cl2 plus, Cl2 minus? Which of them? Cl minus. That's chlorine. Now, why Cl minus? Let's analyze it. Look at this place. Chlorine, please. Look at this now. Chlorine, what's the atomic number? 17. So what will be the configuration here? 2, 8, and what there? 7. Alright. This man, is it stable? Of course not. Of course not, it's 7, so it's not stable. It's not octet, that's 8. It's not duplet, that's 2. There are two ways for this man to be stable. It's either this is 7. It's either to lose 5, Abby. You have to become what there? Duplet. That's 7 minus 5 to give you 2. That's duplet configuration. Or it can simply what there? Gain 1 to become what there? 8. Octet configuration. So between losing 5 and gaining 1, which was easier? Gaining 1. So you now gain 1 electron because of the Cl minus. That's gain electron, 1 electron to become Cl minus. That's the concept behind writing all these things there. Right? That's it. We good? Alright. So that's like the concept. I don't know. Do you want to jot this one down? Or should we proceed? Just write some in your language, so you understand it. Right? If I say Cl minus, you know why it's a minus. So you can actually predict this stuff. It's not always like this, though. In some cases, it's different. In some cases, but this is like a basic idea about this matter. Alright. We discussed ion yesterday as what there? An element, Abi? Or a compound what there? Electrical charge. What's a radical? Let's look at this, please. Please, before we go, take the definition. Radical, definition. A radical is simply a group of atoms. A group of atoms acting as a single unit. A group of atoms acting as a single unit. Alright, that's like a radical. Let me explain what that means, please. So I have hydrogen alone there. This is an element. For radicals, if you observe your if you observe your compounds, right? You hear sodium trioxocarbonate, something like this, right? Trioxocarbonate, sulfate, all these are called what there? They are called radicals, right? You can see this now. This is not some element. This is a group of elements. Carbon and then 3 oxygen. But they always act as one. So this is called what there? A radical. You have H2SO4. This one here is a radical. SO4. They always act together. So that's like radical. Take that place. Some popular radicals. Print them there. Serial number. Radical. Valency. Serial number. Radical. Okay, radical. Put formula first, right? Formula. And then Valence. Alright. Serial number. Radical. This is this. Alright. If you're good, I'm good. Can we start? Number 1, please. Ammonium. Number 1, please. Ammonium. NH4 plus. Valence is 1. Number 1, ammonium. NH4 plus. Valence is 1. But 2, hydroxide, that's OH minus, becomes what there? Still 1. Hydroxide, OH minus, that's T1. This one is trioxo nitrate 5, that's NO3 minus, that's 1. Dioxonitrate 3, that's NO minus, still 1. Let me bring some to your notice. Alright, so these are like the other ones, but let's play with these ones. These 6, right? Ammonium hydroxide. Please note this stuff. I will ask you to write the name of a compound for me. You write it for me using this concept. Right? Right. Why is it that for this one here, if this man, of course, this means that this is what they're gaining a bit. Man, this is what they're gaining electron. Question is this: how many electron is this man gaining? How many? Huh? 2 now. It's easy. Why 2? 2 minus. This is gaining what there? 2 electrons. That's all. Look at it. How many is this gaining? Just 1. Right? How many is this gaining? That's 2. How many is this gaining? Losing. Some people say it's gaining 1. It's plus, it's losing, not gaining. Plus. Alright, so now here's what you should notice. How come I'm writing SO4 2 minus? How come is this and not SO4 minus 2? That's an equation now. It's losing to electron. So how come it's not minus 2? How come it's 2 minus? How come it's 2 minus here? Why is it not minus 2? Why is it 2 minus? Why not minus 2? Why? Pick one. Huh? No what? If it's let's say, let's assume. Okay, fine. Let me say I have an atom A, and this one is gaining 3 or is losing 3 electrons. If it's losing 3 electrons, it's because of that 3 plus, not plus 3. 3 plus. So how come it's minus 2? Or how come it's 2 minus? Why not minus 2? Here's not the concept. Right? I'll digress a bit, I'll come back. We'll look at how to write compounds with this. We are done. We'll do physics, not for today. Alright. Here's the concept. Let's leave chemistry out of it. Leave chemistry out of it now. Right? Let's look at physics. For physics, let's say I want to write the S sign for acceleration. What acceleration? Meters per what there? Second square. True? It's acceleration. In its what do you call it? In its index form, this becomes from there ms what there minus 2. Here's the concept. Obviously, I can write it by saying m times 1 over s squared. True or false? True. So it means that s power minus 2 is equal to what there? 1 over what there? S squared. This is mathematics. This is the concept of indices. Now, this is the thing now. Of course, you know that science is actually what there? A body of knowledge, right? Chemist, the scientist, biologist, the scientist, mathematician, the scientist. Now, pick out a scientist at random, right? Pick out anybody at random right? Let's say it's a mathematician, and I say mathematician come. I write S bar minus 2 for a mathematician. What comes to his mind? What he's seeing is what? Equal to 1 over there, S squared. That's mathematics. Pick out a chemist. Tell a chemist S bar minus 2. What's he saying? He's assuming that this means what there? Sulfur losing what there? 2 electrons. So in other words now, this thing becomes what there? It has 2 different what there? 2 different meanings to what? 2 different presents. A mathematician is seeing what there? Indices. A chemist is seeing what there? Sulfur losing what? Or gaining 2 electrons. True? So to avert, alright, that confusion of is it indices or is it chemistry, what do you know now? We swap it instead. So if I see S2 minus, this one is not indices, this one is what now? It's chemistry. And that's the concept. Because if I put it like this now, it can be confusing. I'm not sure if I'm doing indices or I'm doing chemistry. So to avoid this confusion now, put the 2 here instead. So if I see this one here, it's purely chemistry. If I don't see S power there, minus it comes up there, purely maths. And that's the concept. Yes.
You're trying to say
part there? Yes. Yes, if you got that. Yes. Why S2 minus is not wrong, is still not proper. Because at this point, I'm not sure if you're talking about maths or chemistry. But at this point, if you give this one, I know this is purely chemistry. Maths cannot be like this. And that's the concept. Hope you're good. One last thing for today, please. One last thing for today. Writing compounds using the concept of valency depends on time schedule, right? This time I'll fix in more classes, so learn, right? Well, okay, we'll discuss it after class. Alright, think down, please. Think down. Note that 2 elements can only combine. Note that 2 elements can only combine. Note that 2 elements can only combine to form a compound. Note that 2 elements can only combine to form a compound if they are of opposite charges. Can only combine to form a compound if they are of opposite charges. Full stop. This means that if they are of opposite charges, full stop. This means that atoms of the same charge, this means that atoms of the same charge do not readily combine. This means that atoms of the same charge do not readily combine to form compounds. Of the same charge do not readily combine to form compounds. Are we good? So look at it. So I'm saying it. Alright, are we done? Full stop. Take a paragraph. Take a paragraph. Full stop. Take a paragraph. When atoms combine to form elements, they exchange their powers. When atoms combine to form elements, they exchange their powers, ignoring the signs. They exchange their powers, ignoring the signs. They exchange their powers, ignoring the signs. So look at it. That's it. Look at this. If I have a compound, an element is, let's say X, having, let's say minus A, okay, minus A, or A minus, right? Okay, A minus, combined with the other element, Y, having what here? B minus, to form a compound. What will happen here? Look at this. I'll have this. So we have to, these two, can this combine? No. Why? Same charge. I said you can only combine them on what there? Opposite charges. Alright, so opposite charges minus plus, they can combine. So this is another pattern of Jamb question. They will ask you, this is another pattern of Jamb question. If you go through their past, you see them. Which of the following elements cannot combine to form compound? How do you know? Look at the charges there. They will tell you A, H plus Cl minus. Or this is if they want to be kind, they'll give you these charges. If they don't want to be kind, what will happen? They'll ignore it. B, they'll tell you Ca2 plus H plus. C, will tell you Pb3 plus. Which one do you use there? Okay, let's take this cell here. Or better still, CO3 2 minus. Right, better still. Let's use this one here. Alright, I think I've given some already here. Yep, this. So, which one will be the answer? Obviously B. Why? They have the same charges, they cannot combine. That's the concept. Alright, but let's assume they can combine. What if they can combine? How do I form the compound? Look at me, I said they will exchange their parts, ignoring signs. So these two can combine, minus plus, yes. So what next? This man goes this way, yeah? This one here goes this way, yeah? But you now ignore the part. So it becomes X. This B comes here because of there. Observe, it's now B, not plus B. Next up, I'll have Y. This A comes this way, and because of there, A. This is what the compound will look like. This is what the compound will look like. So that's like the case. Example. Let's say I have sodium Na plus. Combine what there? Chlorine Cl minus. I have this. What compound will form? Look at this now. Becomes NaCl. What's the substance here? This plus 1. So 1 is coming this way. It becomes 1 here. This is minus 1. 1 is coming this way. It becomes 1. I'm having 1 and 1 here. It can be ignored. And this is why sodium chloride is what there? NaCl. That's the concept. Let's use water. Hydrogen is H plus. Oxygen is what? O what? For oxygen, what's the thing there? 2 minus. Become 2 minus. So can they combine? Yes. Why? Positive, negative. If they combine, what do they form there? Becomes H and O. We said this part comes down here. What number here? 2. Becomes 2 here. Yes, 1. Having H2. Put 1 here. This is the concept of writing compounds using what there? Valency. Alright? You can copy this, let's proceed. This is like the concept, right? Number 1, they must be of opposite charges. Number 2, when they exchange, what happens then now? They ignore the parts. Alright? They ignore the sign. Minus. There's no minus here, it's just 2. And that's my concept. Let's proceed please. Next up. 1 line space. Paragraph. If two compounds of opposite charges, have the same number, they cancel out. Has the same number, they cancel out. Has the same number, they cancel out. So look at this case. What if I have X and then A minus combining with Y, A plus? What do you observe here? Opposite charges, so they can attract, but yet still the same number, A and A. What happens? The same concept, I'll have X, Y. We just said this one will go this way, so I'll have A here. Also, this one will go this way, I'll have A here. But let's not the difference is. If they are the same, what happens now? This cancels this. We don't see what there? X, Y. This people please. X, Y. An example is this. Let's say I have calcium oxide, right? Or calcium dioxide. For calcium dioxide, calcium is Ca what there? 2 plus. Combined with oxygen, O2 minus. Right? We say concentration. So what happens here now? This becomes CaO. Abi? 2 here, 2 here. What happens here now? This will cancel this. It gives you what there? CaO. This is called calcium dioxide. Or calcium dioxide. So see the way this works. This is actually a past question. So remember they said which of the following is the correct formula of calcium dioxide. So know why they cancel out. Funny enough, they gave CaO. They also gave Ca2O2. First one there is what there? CaO, not 2O2. These two cancel out. So please take note. Take note. Cancel out. Let's look how they name these compounds. One last thing, please. Some compounds have varying, some compounds have varying oxidation number. Some compounds have varying oxidation number. Such as let's say we have lead, that is Pb. We have copper, that's Cu. So see, for this one they have what there varying, so it's not just one. Right, so some can have like 2, can have 3. Right. Now look at this one. This is called lead 2 ion. This is called lead 3 ion. How do you pronounce this? Not lead though. No, it's not lead. It's actually spelled lead. Pronounce what there? Lead. Right? Don't say lead. I think the concept is still the idea of English and chemistry. I think that's it. Right? In English, this is what lead. Is the past as what there? Lead. So this is what I'm telling now. Lead. Lead in chemistry class. It's something about Moses and right? So the difference between the English lead and chemistry lead, we now call it what there? Lead. That's the concept. So if I say lead in chemistry class, it's spelled lead. You pronounce lead. Alright, so look up here. Let's have to write lead 2 triazonitrate 4, for instance. Lead 2. For lead 2, why is it 2 plus or 3 plus? Lead 2 becomes 2 plus. It becomes Pb 2 plus. Please check. Triazonitrate. Let's see if there's how much. Is it 5? Minus a bit? Minus 2 of which of them? 2 minus. Huh? Check. 2 minus. Just minus now. So look at this. Look at this. Let's have combine these two. This now. Look at it. This becomes obviously 1 will come this way. So it gives you Pb. Next one. The 2 will go this way. Mind you, you don't say NO32. It's now NO32. That's wrong. So in the case where I'm having this is called a radical group of atoms acting as one. In the case where this 2 is coming this way, I'll use what there? A bracket. So use bracket and put what there? Put 2. This is how I write it. It affects everything there. So put a bracket. Alright. So what if I'm to write? So this becomes lead 2 triazonitrate 5. So alright, what if I'm to write this? If I'm to write lead 2, okay, help me out please. Help me out please. Write lead 2 triazocarbonate 4. What would you get? Lead 2 triazocarbonate 4. Check your radical table. I've given you triazocarbonate 4 already. So what would it be? Lead 2 triazocarbonate 4. What would it be? The 2 cancel, Abi. Right. Alright. What we don't find the continue from here, right? Look at how to name. See if I'm asked to name this now. This is lead 2 trioxonitrate. Trioxonitrate what? Is it trioxonitrate 5? Is it 4? Is it 7? How do I know? I'll show you the next class. Take down. Let me give you just take down sample problem. We'll end with this. Sample problem. Limestone used in making cement. Limestone used for making cement is got by combining the element calcium. Limestone used for making cement is got by combining the element calcium with trioxocarbonate 4 ion with trioxocarbonate 4 ion. What is the correct formula of limestone? So you get it. So this is like this way Jamb says it. What is the correct formula of limestone? So you get it. Only bit. CaCO3. Right? It becomes Ca2 plus 1 there, CO3 1 there, 2 minus. That's the concept. I give you some before now. What's the formula of limestone? Say calcium and trioxocarbonate 4. That's these 2. What happens now? These 2 must multiply. I'll go this way now and we'll cancel out. On another spot there, CaCO3. That's the concept. So they cross and cancel out. It's 2 and 2. Cancel out. Alright, let's round up here. I will send some past picture on this, the WhatsApp group. On the one we want to do the WhatsApp group. Goes from there.